the Champlain Sea, the Messinian, the Paratethys, the Pebas Sea, the Western Interior Seaway. Behind all these exotic names that you may have never heard of are fascinating bodies of water that existed on our planet's surface for millions of years before disappearing. Today, I'm taking you back in time to discover, in the depths of time, the surreal landscapes of truly gigantic seas. They died of thirst after a long agony of salt and sun that drove them to evaporate in indifference and silence. Like those that vanished suddenly and violently, trapped between two continents, suffocated by rising mountains, buried under sediments, or swallowed by forests. That being said, without further delay, let's begin our journey by discovering a sea that literally split a continent in two, the Western Interior Seaway, which for nearly 35 million years took the form of a gigantic watery scar opening up in the very heart of North America, to the point that at its peak it connected the Gulf of Mexico to the Arctic Ocean. The Western Interior Seaway emerged in the Cretaceous under the combined effects of major tectonic movements and global temperatures, which escalates due to an intense greenhouse effect. Because this sea forms in a world where the average global temperature is 6 to 10 degrees higher than it is today, and where carbon dioxide levels in the atmosphere reach concentrations 5 times higher than what we know today. So, on this overheated planet, the polar ice caps have completely melted, with the terrible consequence of raising the level of all the world's oceans by 200 meters above their current value. In North America, rising water levels will use tectonic plate movements to split the continent in two. Because in the west, the uplift of the first mountain ranges causes the center of the continent to sink, turning it into a vast depression into which the ocean gradually pours. At its peak, in the late Cretaceous, about 85 million years ago. The Western Interior Seaway is 1,500 kilometers wide and stretches for nearly 5,000 kilometers, covering a total of almost 4 million square kilometers, an area comparable to that of the Mediterranean. Today, sometimes thousands of kilometers from the coasts, we find in the geological layers of the North American Great Plains fossils of ammonites, giant mosasaurs, and bony fish, and so many species that swam for millions of years right in the heart of the continent, in a sea whose presence has had a lasting influence on the evolution of land dinosaurs, isolated on either side of the Americas, living on two giant islands separated for millions of years. The shores of this warm sea, where the surface water temperature must have ranged between 20 and 30 degrees, looked nothing like the temperate landscapes of conifers or ferns, deciduous trees of North America that we know today, because at these latitudes it was so warm at that time that the climate was tropical. And the coasts, like the surrounding inland areas, were covered with lush, humid forests, bathed in air heavy with water vapor. Although the Western Interior Seaway was largely open to the global ocean, its shape kept changing over time. Because its shallow depth, which rarely exceeds 200 to 300 meters, makes it extremely sensitive to the slightest variations in average sea level, as well as to changes in tectonic configuration, which led to the emergence of the Rocky Mountains. It is, in fact, the continued orogenesis of these mountains, whose erosion fills part of the sea, combined with a gradual lowering of sea levels that will mark its inexorable retreat. And when the Cretaceous comes to an end, it withdraws for good, leaving behind a continent entirely exposed to the open air. Now let's head towards the most chaotic of all the seas, the Paratethys, which has constantly changed shape and size for nearly 25 million years. The Paratethys is a kind of late and capricious echo of the Great Tethys, and began to form about 34 million years ago, when the slow collision between Africa, Arabia, and Eurasia fractured and broke up the ancient Tethys Sea, giving rise to a vast, semi-enclosed inland sea, which stretched, trapped between the rising mountain ranges of the Alps, the Carpathians, and the Caucasus. At its maximum extent, it covered about 3 million square kilometers, an area comparable to that of the present-day Mediterranean, and formed a vast continental body of water stretching from west to east for nearly 4,000 kilometers, from the alpine region of the Sents to the borders of Central Asia. which made it, at the time, the largest inland sea on the planet. For most of its existence, the Paratethys had warm waters, with surface temperatures ranging between 18 and 25 degrees. But unlike the open tropical seas with clear waters that one might be tempted to compare it to, the Paratethys was, most of the time, clouded by the colossal amounts of sediment carried by rivers from the surrounding mountain ranges. And above all, this semi-enclosed sea, in constant motion, would experience all sorts of changes because its shallow depth, often less than a few hundred meters, made it extremely sensitive to changes in its environment. Thus, the history of the Paratethys is marked by an almost chaotic alternation between intermittent connections with the ocean and periods of isolation. And this constant instability subjects this inland sea, trapped and confined between unstable landforms, to dramatic changes in its water level and salinity. Each time the uplift of a landform closes one of the straits that connected the sea to the rest of the oceans, its fate is determined in the mountains and the clouds by the distribution and strength of the rainfall patterns. And the Paratethys can be transformed, in just a few thousand years, into a strangely barren world, or into a kind of extremely dirty, salty, fragmented sea. When the sea becomes trapped during hot and dry climatic phases, it gradually breaks up into a series of gigantic shallow basins where sea salt concentrates through evaporation. By contrast, when the prolonged isolation continues during wet climatic phases, the waters of the powerful rivers that continuously flow into it dilute the sea, which turns into a gigantic body of brackish water, regularly invaded by algae. The fragments of the Paratethys gave rise to so many different subgroups that it would be presumptuous to try to describe them all to you here. But one of the most astonishing is perhaps the Molasse Sea, this strange, shallow sea that formed intermittently in the heart of continental Europe, nestled in the long depression that was carved at the foot of the Alps after the African plate collided with the Eurasian plate. For millions of years, in the trough parallel to the emerging mountains, a sea in precarious balance took shape. Because even though it could stretch at times for nearly 1,000 kilometers from west to east and reach 250,000 square kilometers, the Molasse Sea was, from its very birth, a body of water living on borrowed time. Because its position makes it a huge receptacle for debris, constantly fed by erosion coming from the sides of the mountains, worn down by the combined action of rain, rivers, and landslides. As long as the sinking of the basin in which it settled, and which is subsiding under the weight of the Alps, wins out, the Molasse Sea persists. But as soon as erosion takes over, it gets buried under the debris coming from the mountains that allowed it to form. Until finally, 20 million years ago, the Molasse Sea ended up being completely buried by the sediments of a continent. Now let's jump forward in time, 10 million years after the Molasse Sea was buried under the debris. The Paratethys, thanks to a particularly pronounced wet period and the uplifting of the mountain ranges, will turn into a rudimentary lake, completely isolated from the rest of the oceans for several 100,000 years. A lake that stretched from Central Europe to present-day Kazakhstan, covering an area of about 2.8 million square kilometers. And it alone contained nearly 10 times more water than all the lakes currently present on Earth. In rocks dating from that time, we find fossils of the smallest known whale species, which, in order to adapt to the very particular conditions that prevailed there, became smaller in size, to the point of being barely larger than a human. Then, the brief existence of the strange Paratethys lake would come to an end, as the region's climate began to enter a drier phase. And after changing its appearance dozens of times, Paratethys began its final disappearance by breaking up into smaller parts. The unified system that unravels into several pieces is replaced by a mosaic of small residual inland seas and lakes with no direct connection between them. Today, the Black Sea, the Caspian Sea, and the Aral Sea are, in fact, just ghosts of Paratethys, the remaining fragments of an ancient giant trapped between the continents. Up until now, all the vanished seas we've talked about have persisted, in one form or another, for tens of millions of years. But exceptionally, there are cases where seas form and disappear in just a few millennia. This is the case of the Champlain Sea, a sea as sudden as it was short-lived, which appeared for just about 1,500 years in eastern Canada at the end of the last glaciation. 12,500 years ago, just as the North American ice caps had only just retreated from this region, the rocks that had borne the weight of the glaciers for tens of thousands of years were still deeply pressed down. So, once the ice retreated, the waters of the Atlantic Ocean could quickly rush into the St. Lawrence Valley. In just a few centuries, this transformed a vast continental region into a cold inland sea. At its maximum extent, it covered nearly 200,000 square kilometers, an area comparable to that of the present-day Adriatic Sea. And then, as the rocks were freed from the colossal weight of the ice, they began to rise, and the waters of the Champlain Sea were pushed back toward the ocean, while the St. Lawrence River reclaimed the landscape in just a few centuries. Today, in Quebec, we sometimes find areas located several dozen meters above the current sea level and several hundred kilometers away. Inland, there are fossils of crustaceans, fish, and even the remains of whales that lived in this ephemeral sea. Without further ado, here is now the strange Pebas Sea, which emerged 23 million years ago in western Amazonia, in the form of a gigantic rough tropical body of water trapped in the heart of South America. And what is very strange about it is that it resulted less from the invasion of land by an ocean than from the inability of a continent to drain its waters. As if Amazonia couldn't decide whether it wanted to be a sea or a forest. The story of the Pebas Sea begins in the Miocene about 23 million years ago, in an explosive tectonic context where the South American plate, which collided with the Nazca plate, began to raise the Andean Massif and profoundly disrupt the continent's hydrology. Before this uplift, a large part of the region's rivers flowed westward toward the Pacific or joined the Caribbean Sea to the north. But as the Andes rose, the emerging reliefs redirected these flows into the gigantic depression that sank to the east of the mountains. In this basin, several hundred kilometers wide, the rivers and streams joined together to form a giant hydrological trap, flooded by seawater from the Atlantic and by rainwater from a quarter of the South American continent, which poured into it, making the Pebas Sea the largest continental aquatic system of its time. At its peak, about 16 million years ago, this sea covered nearly 1.5 million square kilometers, which were transformed into a gigantic labyrinth, rough expanses, dotted with swamps and mangroves, and surrounded by flooded forests, between which interconnected and shifting waterways flow, redrawing the curves of the shoreline with each rainy season. In this patchwork of shallow channels, where fresh water regularly competes with salt water that rises from the opening, which forms intermittently, in the Caribbean Sea, there are giant freshwater dolphins, colossal crocodiles, as well as many other unique species that have adapted to the very special conditions of this sea, which has no modern equivalent. A sea that, when the connection with the Atlantic Ocean is temporarily cut off, resembles an oversized tropical version of the Okavango Inland Delta, forming an absolutely gigantic basin filled with water whose level rises and falls with periods of intense rainfall. A million years after the Pebas Sea reached its maximum extent, hundreds of thousands of square kilometers in the south of the continent are submerged under the waters of the Atlantic, which, during a particularly warm period known as the Middle Miocene climatic optimum, flooded the low plains of Argentina, Paraguay, and Uruguay. This inland sea will gradually recede as the formation of the Antarctic ice sheet, which stores more and more water in its ice, causes the average sea level around the world to drop. The Pebas Sea, however, will persist for a few more million years before it is gradually drained and replaced by the modern Amazon River system. Because as the Andes continue to rise, the Pebas Sea is gradually smothered under sediments, while at the same time losing some of its tributaries. One after another, they abandon it and begin to flow eastward, where they give rise to the modern Amazon River system. And the Pebas Sea, killed off by excessive uplift, ends up swallowed by the forest. To finish this hallucinatory journey in style, let's now head toward a sea that escaped through the air, leaving behind a desert the size of a small continent, located several thousand meters below the average sea level. Before filling up again during the advent of a flood, the proportions of which are staggering. The story of this cataclysm begins 6 million years ago. At that time, the Mediterranean Sea had almost the same shape as we know it today. Almost entirely surrounded by continents, it relies on a few narrow passages to connect to the world ocean and continually renew its waters. And this unique geography makes it particularly vulnerable to changes. In just a few tens of thousands of years, due to temperature and tectonic activity pushing Africa towards Eurasia, the Strait of Gibraltar will gradually close. Now cut off from the water supply coming from the Atlantic Ocean, the Mediterranean Sea finds itself completely isolated and begins to evaporate into the air. The reason for this disappearance is that the amount of water brought in by precipitation and by the large rivers that flow into it is not enough to compensate for the evaporation rates of this enclosed sea. Consider that today, the Mediterranean loses about 3,100 cubic kilometers of water each year through evaporation, while precipitation brings it only 1,000. The rivers bring 430, the Black Sea 180, and the Atlantic 1,500. So, once the tap from the Atlantic Ocean is closed, the days of the Mediterranean are inevitably numbered. In the space of a few millennia at most, the majority of the basin's waters will evaporate, leaving in place of the vanished sea. A landscape on an immense scale, made up of burning salt deserts, where in some places it can reach nearly 60 degrees during the day, punctuated by a mosaic of fragmented hypersaline basins and dried-up plains, located several thousand meters below mean sea level. Inside this immense basin framed by giant continental cliffs, the desert formed thick salt crusts that stretch as far as the eye can see, and in some places are crossed by astonishing and improbable streams. Because the ancestors of the Rhone and the Nile, like all the rivers around the Mediterranean, continue to flow. By plunging toward the bottom of the dried-up sea, at the level of their former mouths, they cut into the landscape and carve canyons several hundred meters deep before continuing their course along the bottom. With their powerful occasional floods, they manage to painfully carve a path to the heart of this parched inferno, to feed the gigantic salt lakes that manage to survive in this hell. Even today, we can still find traces of the raw power of these rivers, which, although later masked by their own sediments, are still visible in seismic surveys of the geological layers. Not only did it give rise to surreal landscapes, but the formation of this desert below sea level would profoundly impact the climate of the entire Mediterranean region. Without the sea to soften the contrasts, atmospheric circulation goes wild, summers become hotter, and winters become drier. And North Africa, like southern Europe, is then regularly swept by storms. These storms are loaded with salty dust that they have torn from the ground of this infernal basin. Even today, this great catastrophe, called the Messinian Salinity crisis, during which evaporate deposits up to 2 or 3 kilometers thick accumulated in some places, remains the largest known precipitation of salt in the entire history of the Earth. Just think. It is estimated that the amounts deposited during the evaporation of the Mediterranean, which still lie at the bottom of the sea today, represent 6% of the salt dissolved in all the oceans on the planet. Then, after nearly 650 million years of existence, this desert from another era suddenly disappeared, and the Mediterranean was reborn from its ashes. When violent earthquakes cracked open and reopened the Strait of Gibraltar, triggering one of the greatest floods in the history of the Earth. According to the latest models, it is estimated that the waters from the Atlantic, which abruptly ended the history of this desert located below sea level, had a flow about 1,000 times greater than that of the Amazon, enough to raise the water level in the reborn sea by nearly 10 meters per day, and to completely fill the Mediterranean in less than 2 years. And since, according to the well-known principle of communicating vessels, which tells us that when you fill a bathtub, you have to take the water from somewhere, once the deluge was over, the global level of all the oceans on the planet dropped by nearly 6 meters. The traces left by this torrential reflooding are still inscribed today in the topography of the deep sea. Thus, data collected from seismic survey campaigns and the study of alluvial deposits have, for example, shown the presence of a huge erosion channel, several hundred meters deep, stretching for 390 kilometers from the Gulf of Cadiz in the Atlantic Ocean to the Algerian basin. To carve out such a channel, the roaring rivers must have torn away around 1,000 cubic kilometers of sediment along their path. Farther to the west, nearly 1,000 kilometers away, another canyon has been found on the seabed near the island of Malta, 5 kilometers wide and plunging nearly 1,500 meters toward the eastern basin. It is believed that it was here, after first filling the western part of the Mediterranean, that the water poured into the other side. A few hundred kilometers from these underwater cliffs in the Ionian Sea, 1,600 cubic kilometers of sediments deposited by a sudden flooding phase have also been found. In short, the Earth has changed its mind more than once about where to place its waters. World maps are open parentheses, screenshots of a planet in motion. And the memory of the vanished seas that we just flew over is still written everywhere in the rocks that make up our landscapes. Today, the vast farmlands of the plains of Kansas, Nebraska, or Dakota, which rest on the ancient seabeds of the western interior Seaway, are nourished by the fertile, organic-rich sediments that settled at the bottom. The legacy of the Paratethys is also woven into the landscapes of Hungary, Romania, or Ukraine, where the marine deposits have turned into sedimentary plains rich in silt and extraordinarily fertile clay. Meanwhile, many of the oil and gas deposits in the Caspian Sea come from the breakdown of organic matter that was deposited in these shallow basins. Remember that the next time you go for a walk. The ground beneath your feet has probably been underwater at some point in its history, and the sea could very well come back there one day. Here, you'll find a playlist to discover other episodes dedicated to the mind-blowing landscapes from our planet's past. Since YouTube's algorithm is currently acting up, feel free to leave me a comment, share this video, or give it a like. It always helps with visibility. And let me know which seas you would have liked me to talk about that I didn't mention.